So in this video section, I will show you how to integrate your Smartrek Smart Gateway Plus data into VTScada. So in my demo, I'm using VTScada Lite, which might differ a bit from your own version, but I think it's still going to be pretty similar. So first, let's talk about the different options that the Smart Gateway Plus offers. So the Smart Gateway Plus is the most advanced gateway platform that Smartrek offers. It's a full-fledged computer with enhanced capabilities. And of course, it collects and stores data from the Spider Mesh network, just as the other gateway platforms. And then it also sends the data to Smartrek's cloud application. Or it can also send data out to one of your platforms, so your SCADA system, for example. So it can do that using either our REST API, MQTT, Modbus RTU, or Modbus TCP. So in this video, I'll be showing you how to integrate using Modbus TCP, as this is the most commonly used communication protocol. So let's get into it. So first, let's get our Modbus table out of our Smartrek system first. So to do that, we're going to need our IP address, actually the IP address of our gateway. So there are several ways to do that. You can find information on your router, of course, or you can use a network scanner. But in my case, I'll simply open up SGC, which is the Smart Gateway Configurator software that we provide, and it does the job of detecting the smart gateways on your LAN network. So I'm going to open that up. I don't know if I have, okay, I have opened it up. So while it's loading, I'm going to talk a little bit about what kind of information that you can find in the Modbus registers. So on your Smartrek system, you might have a bunch of sensors, some of which you can control an output, and others that you simply read sensor data. So by default, each sensor added to the system will appear in the Modbus table automatically. This is kind of the default behavior, but in some cases that might not be what you want. So we also have the option to have the table configured by Smartrek with specific values assigned to the registers of your choice. So you can't really manually specify that table, but we can do that on demand, so just reach out to us. Also, when the table is pre-configured by us like that, then you can also add mathematical expressions to derive values from multiple sensors. So for example, you might want to get the pressure differential between two devices and output that into, say, register 300,050. Well, no problem. We can do that for sure. All right, so the available smart gateways have loaded in SGC. So let's take a look. So to find my current smart gateway, I have to look onto my device. So on my smart gateway and check on the label for its MAC address. So in this case, this is not the smart gateway that I'm trying to connect to, but still you get the point. So the label is on this side, on the side of the antenna, and you will find the MAC address over here. So my MAC address is 0.1.126.95. So I know this is my gateway. And so my IP address is 192.168.0.145. So let's go ahead and copy that. I'm going to open Notepad and we're going to write that down. So IP address 192.168.0.145, this. And so now with the IP address, I can now get my Modbus table. So, oops, I already opened that. I'm gonna do that again. So open up a browser and then you can head over to 162.168, oops, .0.1. Well, you would enter the IP address of your gateway here. with port 8080. So don't forget this colon between the IP address of the port, and then slash sd slash dinma.csv. That's no good. Oh, 168, sorry. So 168, like this. All right, so now I have my Modbus table in a CSV format. So I'm going to copy that and put it on my notepad, and it's not really nicely formatted. So I have it somewhere else. I can drag and drop this. All right, so we have our Modbus table here. Yep. All right. So now that I have my IP address as well as my Modbus table, I'm going to be able to start the integration. Oh, also note that I could have fetched the table from SGC also, but I find that it's kind of more convenient to do it in the browser like that. So, but you can do as you wish. All right. So before we start integrating, I always recommend to test that you can actually reach the Smart Gateway and that you can pull the Modbus registers before starting the integration. So let's start with a more lightweight software to test our Modbus connection. So I'm going to use QModMaster. Oops, sorry, I have to open it up like so. So QModMaster, which is a free Modbus TCP and RTU master software. So yeah, I've downloaded it. QModMaster. I've downloaded it from SourceForge here, so you can find the download link here. But obviously, you can choose any other software. There are plenty of options online. I like this one, but any other one would do. So yeah, so let's go ahead and first select TCP here, and then we're going to enter the connection parameters. So click on options, then Modbus TCP, and here we're going to enter the IP address of our gateway. And the TCP port is the default Modbus port, which is 502. So click on OK. Next, we're gonna click on settings, and we're gonna OK. So I don't know what is the value here for you, but just put something very high here. So 20 seconds is fine. And then we can maybe open up the bus monitor to see what's going on. And then we can connect. And so we have the message here that it's connecting OK. So next we can try to read a Modbus register. So maybe we could try to read, let's say, what can we read? Do I have voltage? Yeah, maybe I can read the voltage here. So how about the voltage, which is at register 525. So I'm going to enter 525 here, and I'm going to select read input registers, because this number here starts with 3. So let's go ahead and maybe we want to read only 2 registers like this. So click on read, and there you go. So we have the value here. So it should be this register here. Yeah, 525. So the value that I'm reading is 90. I know there's a scaling of 20, so that means that I'm going to open up a calculator like this, and so it means that I have 90 divided by 20, so the sensor is currently at 4.5 volt, which is the expected value, so all good. Note that some of the older version of the QModMaster software and also the Linux version They use a zero-based addressing mode, which means that you might have an offset here on the address. In my case, I'm using a want-based addressing mode, so that's why the register 525 correspond to 525 here. But in your case, maybe you have to enter 524. So just play with it a little bit and try to figure out which version you're really using. Whoops. Okay. All right, so since everything is working fine, now I'm ready to start integrating to VTScada. So we can close this, and then I can launch VTScada. So let's go ahead to the application. This might take a while. All right, so it finally opened. So I'm going to move this over here, and we're going to be able to start integrating. So let's start with a blank page. And so let's start integrating. I'm going to put this down a little bit, like so. So now that we've opened up VTScada, we can select Tag Browser here. And then we can first create a new context. So let's give it a name. Smartrek Demo, that's fine. Okay. And then within my context, I'm going to create my connection. So I'm going to select TCP IP port. If you don't have it on top here, then you can select all tags type and scroll down to TCP IP port. I'm gonna name that port, that's fine. And yeah, the connection I've done it before, so that's why it should be empty here, but you have to enter the IP address of your gateway, and then of course the port, which is 502. Next, we're gonna add the driver. So in this case, select Modbus compatible device. We can name that driver. As I say, it remembered the last time that I've created something, so that's why it's already selected. I think by default it selects serial RTU, so make sure to select Open Modbus TCP. Normally nothing is checked here, but with Smartrek system you need to check both of these, which is the byte order for the floats. Next, you can click on communications, and then we need to select the port, so the connection to our smart gateway. So let's go ahead and select port here in Smartrek Demo. So select and click on OK. So now we're ready to create a tag. So create a new child, and let's select let's say the same register as we've done with QMod master. So register 525 would do. So it's a unsigned 16-bit integer. So when I get click then on analogs and IO and calculations. Yeah, I've created that before. So let's name it tag 1. And then click on IO, select the Modbus driver. And then, okay, so normally this is empty. So here we're gonna have to enter the read address. And how are we going to do that? So we're gonna fetch the documentation. So I'm gonna open that up for you. So on VTScada documentation, you're gonna find the Modbus compatible devices IO addressing. And so, for example, it says that a holding coil, you can refer to holding coils with HC. The same goes for input coil. You use IC, and what we're going to use most is input registers as well as holding registers. So just remember that input registers should be IR, and holding registers should be HR. And so let's go ahead and enter IR because we want to read input register 525. Yeah. And then next thing that we need to do is specify which type of data that we're reading. Is it a bit? Is it a float 32? What is it? So I'm going to whip out the documentation again. Sorry. So we have data suffixes. And in my case, I know that I have an unsigned 16-bit integer. So I'm going to have to specify that by using /uword. So let's go ahead and write uword. And then if you look into the table here, you can see that there's a scaling, right? So remember that we've read that this register in QMod master gave us 90, but then we had to divide that by 20 to get 4.5 volt. So let's see what you're going to get if you don't put any scaling. So if I click on OK, I should get a value here. So I do get 90, right? But which is fine, it's the correct value, but I might want it you know, with this scaling taken into account. So I'm going to select the properties of this tag here, and I'm going to go into scaling. So you can see that the scaling is by default 0 to 100. So what you need to do then is to multiply 20 by 100. So that's going to give me 2000. And so that gives me the 4.5. So I don't see the 0.5. I don't know if there's a way to display the decimals here. But hey, what we can do is we can add maybe a widget here, something to display the data. So it's going to be clearer. So I can close this. And then maybe I can add a widget. Where are those? Not text. Oh, maybe this one here. So properties, I'm gonna select a tag. So I'm going to Smartrek demo, and then I'm gonna select my tag 1, select, and then I can adjust digits after decimal. So let's go ahead and 3 decimals, like so. Okay, maybe we can add some text. Just maybe multi-line text. And we're gonna write voltage register 5. Well, 300, 525. All right, so that's perfect. So next, we can add another tag. So you can see the question mark here, so we can remove that by selecting, hang on, I think it's here. Okay, I can unselect questionable data, like so. Okay, so let's add another tag. This time maybe we can use a float 32. I'm gonna try to find something that has a value. I don't have a lot of options here. I could select those, but I know that they're currently measuring 0, so that's not going to be helpful. Oh, maybe I can use M process value, which is hang on. No, let's take yeah, let's use current percentage here. So I'm going to, oh, this time it's not an input register. See, it's a holding register. So we're gonna still select analog here. Then I1 calculations. Let's give it a name, type 2. And oh, it's the same node, but this time it's current percentage. And into IO, I'm gonna select my driver. And I'm going to use holding register instead of input register, and it's going to be register 519. Then slash, let's go back into our documentation. And a float, single precision floating point, you have to specify slash float, like so. And so I'm getting this value, which is correct because I know this value should be between 0 and 4,069 or something like that. So, okay, maybe it doesn't give you any indication whether it's working, but I know it's working. Next, maybe we can find a do I have, oh, okay, maybe I can use, I can add this, yeah, I can use this register afterwards. Yeah, so 501. So it's an 16-bit integer, but I know that normally this is a Boolean. How would I know that? Well, normally I would go into the data sheet of that sensor. It doesn't say which type it is, but I guess you can infer that with the MAC address. So the MAC address is on the barcode of the sensor. So I know that this sensor is a relay. So I'm going to add, oh, sorry. Sure. So I'm going to add a new child, and this time I'm going to click on digital IO calculations, and I'm gonna give it this name here. So I guess you can keep the same format, and then it's channel 1. Then I can go into IO, select my driver, and then I'm using the input register, and the register should be 501 slash. Let's head back into our documentation, and I want a bit here. Bit. All right. So you can also control devices from your SCADA system through Modbus. So for this relay node, you can actually toggle channel 1 or channel 2, which will then input a 24-volt signal out of the sensor, which could control an equipment that is wired on a contactor, for example. Which is the case for me. So I'm gonna add this tag. So new, whoops, what did I do? So new child, digitals, IO, tag 4, then, so I'm gonna name it expected channel 1, which is the control of the relay node. Select the driver, and then it's going to be holding register, right? Not because we're controlling, we're writing. It's not an input register. And we don't want to read. That's what I just said. So here we're gonna input holding register here. We don't want to read that. We want to write. So holding register 500 slash it's a bit, and okay. Okay, so next maybe I want to add some widget to control that relay. So I'm going to close that, and I'm going to add, well, first we're going to add the data for a second tag, which was current percentage, I believe. Yeah. Select. We don't want that much digit. Oops. And then I'll name that current percentage. The register was 400. $1,519. Okay, and then maybe we can add a button. Like so. We can maybe add a light also. Where are the indicators? So maybe a round one, like this. So properties, I'm gonna select the tag, which is the state of channel 1 here. Not sure how this one works. And then for the button, I'm gonna select the control, which is this one. And save. And there you go. So if I click here, it should change the state to on, and so it should trigger my relay. There you go. I don't know if you've heard it, but there's a contactor triggering. So the light is not really working, I think. Oh, is it? I think it is. But the state, it should change color, but I won't change that. So if I click on this, it's going to go back to off, and so you're gonna hear my relay triggering again. There you go. If I click here, I should see that it has toggled on and then off again. So I guess that's pretty much it. Another note is that you should really make sure to select these options here. So I'm going to show you what selecting those options means. So here I have a simulation, a Modbus simulation software, which is also integrated into my VTScada here. It's in SimServe here. And so I've the simulator behaves just like the Smartrek system. So if I click on the channel here, which is a driver, I've selected Open Modbus TCP and also selected both options here. And if I go into the simulator and I go into the options here, so you can see that I have set tag 4 into, sorry, register. So into the input registers. So I've created tag 4 and tag 5. Tag 4 being a uint 32 and tag 5 being a float, single precision. And so I've given them these values here, and you can see on my integration that I'm reading the same values. Let me arrange that a little bit for you to see. So see 53,764, that's the same that I have here. And I'm reading 12 for this value here, this float value. And so if I click here, this is how I've configured my Modbus simulator. So this is actually how the Smartrek system is sending data. So you can see the integer bit order and also the float bit order, and also the float word order, which is different from the integer word order. So there you go. This explains why you have to select the reverse order option in here. Yeah. So I guess that concludes pretty much my demo. If you have any questions, don't hesitate to reach out to us. So you can always reach to technical support. So you can simply write an email to support@smartrek.io, and that will create a ticket into our system, and we'll be able to assist you to the best of our abilities.